Open the MIDAS. Now first is unit. So you have to first see the unit, which is the unit you have in the AutoCAD DXF file. So my AutoCAD DXF file unit is mm. So I have to set the unit as a mm from the bottom of my this option. Then I come to the file, import AutoCAD DXF file. So at the time of AutoCAD DXF file, I just say browse and it's asking the which level. I just say first floor, open. My first floor is coming. I just say center. Now this is coming. At the time of year, I can give the property also. Okay. So how to generate the properties? First, you can directly click on this dot dot option. I just click here. I just say add, and it's asking the property type of design is concrete. Always click on the type of design. Depending upon the type of design, it is going for the designing part. Means if you say steel, so in the steel designing this particular grade is using. If you say concrete, so it is for the concrete. Now according to the code, if I say ASTM, I can select the M40 grade, and the modulus of elasticity, Poisson ratio, thermal coefficient, entire thing it is calculated by the program according to the code base. If I wanted to modify it, so in the standard you have to say none, and now you can give your own value. And whenever you are giving the value, check the unit also. I just say apply. Same way ASTM, I will give the next property, that is the M30 grade, and say okay. Now these two properties are generated. Similarly, the import option is also available, so that from the previous file, or we can say from the existing MIDAS file, you can import the data. So this file is also available, means from the only the material grade you can import. So we have means even you have the 4 to 5 files from the MIDAS file. So from the 4 to 5 files you can take the any data. It's up to the you. Just closed it. Now you can see material is asking the grade. So first I'm just importing my beams. So my grade is 300. Now is asking the section. Similarly in the section also I can just say dot dot dot. Now at the time of this add, now I again open my this file. Now here you can see 600 by 600. This is the one my column. Second is 700 by 700. So I can generate this property first, so that at the time of the modeling I can reduce my timing. So first is my solid rectangle. I just give the name 600 by 700. User, I just give the name 600. You can see next to of H it's mentioned the dimension. So according to the dimension you have to input the value. Apply. Sorry, 700, 700, 700. Apply. Similarly 800. If you say apply, the command is still continue. If you say okay, then command is close. So up to the the user, they have to think when they wanted to say the okay, or then when they wanted to say the apply. So I just say apply. Similarly these three properties are done. Now next is beam property. So for the beam property, a beam 450 by 600. So my depth is 600 and my width is 450. Apply. Beam is 250 by 450. So 450 by 250. Apply. Similarly, one more property, that is the 300 by 600. 600. I will just say here 600. 300. Apply. And the last property, that is the bracing, BR 250 by 250. So here it is 250 by 250. So this is the normal procedure. So according to that you have to generate the property. Now I don't want to generate the more property. I can say OK. If I say OK means this command is closed. Similarly, the thickness, if I click here, say add, now in plane and out of the plane, I can say it's a 200 thick, apply, and one more property, that is the 250 thick, and close. Now you can see here, so everything properties are coming. Now I will do one thing, I just say center, and the section is I am selecting, that is the 450 by 600, and just say apply. Once I say apply, now you can see here top view. So this is the my entire per- uh, entire things are coming. But here once I come to the works menu, now you can see what are the things we are defining, it is coming here. So which are defining, that is in the blue color, whichever the property you are defining as well as you are assigning, so that is come in the black color. So if I double click here, now you can see identify, this is the selection, so that all the grades are M30 grade and all the beams are 450 grade. So only this area, this is the beam, I want to change the property. Now you can see here, I just zoom it. So for the zooming, you can use the this command, zoom fit, for this one, and the window zoom also. If I zoom fit in, okay, now if I come to the tree menu, 300 by 600, I just click on the 300 by 600 and drag it to the screen. Now my properties change. So this is the way to assign the properties. So in this way you can assign the property. Now one more thing is, I wanted to import the grid lines. So how we can import? So you have to come to the structure and you have to say dimension. If I say dimension, it is a not, it is the grid, you can directly import, but this grid is only for the reference purpose, means as a image only. You cannot use, means you cannot edit also, it is only the image only. So if I click here, I just give the name grid, grid, I just select the property, I just say grid, is asking the which type of the layer. So I can select the my layer dimension line, grid name, symbol, and the dimensions. I click here. If I say add and the close, now you can see this my grids are coming. Okay. So it's help you to, with the dimension it is coming, and if you wanted to modify it, or if you do not wanted to see, so now same thing in the works menu also it is coming grid. You just right click and you have to say undisplay, so it is gone. If you right click here, if you say display, you can see the grids. I just save this file. The name is say webinar, say yes. Now I just save this file. So next time onwards, no need to save. Program automatically save the auto save features. Now I again come to the my AutoCAD drawing. Now you can see AutoCAD drawing. Here all the my columns are, these periphery columns all are 700 by 700. Internal these two columns are 700 by 700, but these four columns are 800 by 800, and these three columns are 600 by 600. So I just come to the my MIDAS file. I just select these nodes. I just select these nodes. Internal these two, these things, this node, and this node. So now this node I am selecting. If I see the 3D view, just right click on a screen, element, and just say extrude. If I say extrude, a node become a line element. Is asking node to a line element. So from the node it generate the line. It's asking the grade. I can just say M40 grade. Size, I just say 800 by 8, 700 by 700. Dimension, if I want downside, minus 6000, because its dimension is mm. I just say apply. Now my column is generated. Okay, so this is the one method it is available. In this option you can give your properties and these things. I just change my property name. By mistake I give the 600 by 700. Actually it is 600 by 600. Okay, now again I come to the top view. I select the these four nodes, 1, 2, 3 and the 4. I just zoom it. Now again right click, element, extrude, and in the extrude node to line element grade and the size. I will say 800 by 800 and the dimension is minus 6 meter. That is the 6000 mm. Apply. My these columns are coming. Again I will do for this process for 1, 2 and the 3 columns. I need these 3 columns which is the same size. The size is 600 by 600. I will just say apply. Now my entire thing it is generated here. The periphery, we have the shear wall, means retaining wall that we model the later on, because I wanted to copy this floor in the other floors also. Now I wanted to import the next level. I just again say file, import, AutoCAD DXF file, browse. I just give this file name, second floor, open, center, grade, size 450 by 600 M30 grade, and I will just say apply. And at the time of the apply, XYZ coordinate is there. So here you have to mention the dimension at which level you want. Now according to the my level, you can see, yeah, these are the level. Already I model this 6 meter. Now next is my 5 meter. So here I have to give the 5 meter, or else I can directly uh, set the UCS in the AutoCAD drawing also. Now I will just say apply. Now you can see all this model is coming here. Okay, so again I will show you. I just come to the file, import, AutoCAD DXF, select the file. I just say second floor. This is my center, that is my layer, material M30, section size 450 by 600, and I will say apply. My these things are coming, and then you have to say close. Okay, so in this way you can generate the other things. Now one more thing is, I just first select this layer, one level. I just say activate so that I can see only this much part only. Now at this level I wanted to apply the bracings also. So how we can apply the bracing? So I just come to the top view and I just select this area. Okay, this much area only. Just say activate. In this area, from this node to this node and this node to this node, I wanted to generate my bracing. How we can generate it? I just come to the right click, element. I just say create element, general beam and tapered beam, grade M30, and my size is, that is BR 250 by 250. Similarly, I can just say nodal connectivity, first node, this one, second node and this one. Similarly, first node, this node, this node and this node, this node, this node. So in this way we can generate the bracing. Yeah, now these are the my all these things are generated. Generate the all the bracings and these things. Now the next step is, I wanted to copy my all columns. Now you can see this is the all my members. So if I want, I can again go and select the node and I can generate the column. Otherwise I can do one thing. I can just come to my one elevation view. I just select my one this level. So all my bracing and the column I am selecting. Now I come to the structure, control data, and then say building generation. Now in the building generation, I can say it's 2 time because I want here also and the above also. The height is 5 meter. Say add, say apply. Now you can see everything is coming here. So in this part you can see this column, it is not connected to this part. So if you wanted to consider as a one member, then also we can consider. So before that I will just copy this level to the other level. So I just come to the select by plane. I just say XY plane. I just select my one level. I just right click element. I can just say translate. Translate means you can copy and the move also, means you can change this level. So I just say copy in Z level of 10 meter, means 10,000, that is because this is my one level, this is 5 meter and the next is 5 meter. So distance between this point to this is 10 meter. Zero comma 0 comma 1 2 3 10,000, and I will just say apply. Now you can see all this my level is generated. Similarly, next is one more level, file, import AutoCAD DXF file, select the file, fourth floor, center, my grade is M30, size is 450 by 600, and I will just say apply. Now you can see entire thing it is coming here. And if I wanted to select only those particular level, so I can just select this level and just say activate. Now I can see this property. If I wanted to change the property, I just select this beam. I will say it's my 300 by 600. Just click from the tree menu and drag it to the screen. And this is my cantilever portion. That is the size is 250 by 450. I just click and drag it to the screen. Now you can see this is the difference for the changing the or assigning the different properties. Again, I can come here. I can select this particular columns, building generation, and I will say yes, it's a 3800. So if again I come to the my this way, you can see 3.8 meter first. So I will just say 3.8 meter, add and apply. So at the time of the add, you can see this particular three columns. We no need to continue it in the above level. So we can select the left hand side view and you can delete this particular column. If you delete it from the elevation, so whatever the back side of the column also selected. Again, I select my front view, select this particular level, all my area is selected. Now I come here and I can say it's my 5 times, then 2 times 4200 level, say add, and if I say apply, now my this building is generated. So at the time of the generation, again I wanted to generate the my terrace view also. So means over a tank also, I can select the terrace view, top view, and I just select this particular one middle portion. You can see this one, and I will say one time, that is 3600, add and apply. If you see the this entire thing, and if you do not want, I just say active all. Now you can see these things, and if I don't wanted to see the nodes, come to the display of the node and just say OK. So you can see in this way. So this is about the how we can take the model from the DXF file. So anybody having the some doubt or any question regarding the DXF file, if they have any the question, they can type in a question box or in a chat box, so that I will give the some brief explanation up to the DXF import of the DXF file. Okay, so for us, no one is having the doubt regarding the this the DXF file import and import function and these things. Now we started for the next session, next part, that is the about the shear wall modeling. So at the time of the shear wall modeling, we just select our first one level. So at the time of the selection of one level, first we have to generate the story. And one more thing is, you can see everything here. It is from the center to center. I wanted to top to be a flush. So in this way you can see this is everything is from the center to center. So you have to come to the structure and just say structure type. At the time of the structure type, you have to click the convert sulfate into the masses, so that program calculate the masses at the joint. And similarly you have to click on these two options, that is the align a top of the beam section with a floor for a panel zone effect, and similarly align a top of the slab section with a floor for a display purpose. So if I click OK, now I come to the zoom it same portion. Now you can see everything the top is flush, so that you can flush the top. How we can do? Just go to the structure, structure type, and you have to click on the these two options, align top of the beam section and align the top of the slab. Now my this building is generated. Next is come to the control data, just say story. In the story it's asking the story level, so I can just say auto generate story data. I just click here. So according to the Z coordinate, it is generate my story data. I will just say OK, and here it is mentioned the 5% of accidental seismic accidental eccentricity and 15% for the wind of the plant dimension. So I will just say OK. My entire thing is generated. Now if I click here display storage name, you can see my display storage name. Now I wanted to select only the one particular floor or the second floor. How we can select? So you have to come to the view all, and you have to say active identity. In the active identity, you have to click on the story, and in the story you have to select the floor. If I say second floor, and if I say floor active, now you can see only the floor. If you want to see the above column, just click above, say active, so you can see floor and above column. If you say below, so you can see a floor and the below column, and if you say both, you can see top and the bottom columns. Now I will just say below and just say active. Yeah, now this is the my one level. Now I will come here, I will just say select this particular 1 2 3, this one area. Okay, I just select this one area, and I just right click element, and I will say extrude. At the time of the extrude, node to a line element, previously we are selecting to generate the column, but now I just say line to a planar element, means already we have a line and I wanted to generate the planar element. Again, which type of the planar element you wanted to generate? So I just say plate for the this particular retaining wall. So I will just say plate element. My grade is thickness is 250, grade is M40, and I will say here it is minus 6 meter. Say apply. All my wall is generated, and the above beam is deleted because we are saying that my source is removed, so that it's automatically delete the my beam. Okay, now I just say active all. I just select this particular level 1 and the 2 level, these two beams, and just say active. And if I say elevation view, now you can see I wanted to generate the shear wall. How we can generate? Again, I select this particular two level, just come to the right click element and say extrude. In the extrude, a line to a planar element, source is remove. Element type I have to select wall. My grade is 40, my thickness is 250 and consider as a plate element, means in plane and out of the plane movement I have to consider. So I click on plate element, and the dimension is 6 meter. Just say apply. I will just say apply. Now this is the thing is generated. Now next is these two levels. My height is 5 meter. I will say 5 meter. It is generated above 1, 2, 3, 4, 5. And this level, my height is 3.8 meter. And this two level, my height is 4.2 meter. So in this way, my whole the structures are generated. Okay. Now someone is asking out the question related to the meshing and these things. So one by one, I will explain you. First question is about the what if it is the flat slab. So flat slab is again I just show you for the one area how we can generate the flat slab. Here we are taking only the one-way, two-way slab. No need to generate the one-way, two-way slab. Okay, so I will just select here one level and just say apply. Okay, this is my one level. So I wanted to give the flat slab. So you have to come here, nodes and element, and you have to say auto mesh. Just click here. It's asking the line element means periphery beam you have to select. Otherwise you can say nodes. Quadrilateral means four noded or else four noded and the three noded. It is the 1 meter by 1 meter mesh. It is a plate element. Grade. What is my thickness? And if I come to here, I just select first node, second node, third and the fourth. And I will just say apply. Now in this way, my slab is generated. So according to that, you have to generate the slab. So you have to directly take the periphery from the AutoCAD DXFs and then you can select that particular periphery and you can generate the your slab. Second question is about how can I import the column. So column also you can import from the AutoCAD DXF. Only the thing is you have to generate the one line in a 3D direction means in the Z direction. So you have to prepare your model in the 3D form in the AutoCAD and then you can import it here so that all the columns whatever the size you are giving so it's automatically coming here. So this is also the facility we have, but only the thing is that particular column you have to generate it manually in AutoCAD. So these are the some options are available to generate the columns and the flat slab by using the AutoCAD DXF also. Yeah, now I come to the next part. Yeah, now about the next part is the loading. Okay, how we can give the loading and these things. Now for the loading, before going to the loading, I have to give the boundary condition means which type of the base supports are there. So I will just come to this option, select by plane. I just select, I just say XY plane and I just select the bottom nodes. If I select the bottom nodes, you can see all my nodes are selected. If I right click boundary and just say support, right click boundary and I just say support. In the support, D all that is the translation and R all that is the rotation. I just say replace, say apply. Now all my support is fixed. If I say redraw, so you can refresh it the window. Next is at the time of the tree menu, you can see all the my thickness of the wall. It is coming 200 as a blue mark means everywhere I'm defined as a 250 thickness. So I just double click here and I will just say activate. So all above levels. So I just select this particular levels and I just say 200. Just drag it to the screen. Now above wall it is 200 thick and the below it is 250 thick. So in this way you can change the property of the elements. Uh, if you have the one more question is asking, that is 1 minute. Yeah. So question is asked by, okay. If you want to import the AutoCAD file for as a flat slab, and you want to import the column point, yes, you can import. You can generate the your AutoCAD drawing and generate the slab elements. Each and every panel it generate the node, and that particular node you can directly take into the MIDAS in the DXF file. So this type of the things also you can generate. Is it clear your point? Yes, sir. For the column also, because if you know the point in the AutoCAD DX AutoCAD files, means I just open the one my AutoCAD file. Okay, see this is the my AutoCAD file. Okay, yeah. So this is the one my AutoCAD file. If I delete some portion, so if I delete this particular portion, yeah. So these are the some levels. So you can directly import this line as a AutoCAD DXF these things. So this to this area is totally flat slab, and this particular beam also you can import, and at the joint of this particular beam, means at this particular the node you can directly get it from the MIDAS gen. Then you can delete this beam. This way also you can do, or else you can generate here as a draw one point. You can draw the one point at the center, and particular that point you can import it into the AutoCAD DXF file. So this way also you can import the column. No, it is the two way, means you can draw the line also, or else you can draw the point also. If you draw the point in the AutoCAD, so it is automatically take care and it imported into the MIDAS gen. No, it is the like we can say it is a like a one it is in the one layer form. So if you say it is in the layer form, then you can import it. Okay, for you I will generate the one AutoCAD file and I send it to you so that you can import that particular file then. Okay, because the means it's take the timing for me to generate this AutoCAD file and again import it. I have to again generate the my layer and these things. So give me some time. I will generate one AutoCAD file and the same file I will send you, and even I explain you about the how we can take the entire thing. This way also you can do. Okay. Yeah. So okay, I just minimize these things. I just come to here. Yeah, now next is about the loading part. Okay, so we fix the our base support. Now I come to the loads. First is in the static load, we have to define the load cases. I will just say static load case. First is self-fed, type is dead load, add. This is the only the name of the cases. Okay, no need to define any coefficient and this thing for the lateral loads. It is only the name you have to define. Then SIDL, that is the support import dead load. Then live load, LL, my type is live load. EQX, normal earthquake X I am considering. Earthquake, add. Earthquake Y, add. WX1. Similarly, for wind, we have the 12 load cases according to the ASC 710. So we just generate this load on structure 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so in this way we can generate the 12 load cases. I just say close. Now my load 12 load cases is generated. Now I come to the first option is load, static load, structural load, that is the self-fed. So in the self-fed you have to click here and just say SW, that is the self-fed. So in the self-fed I wanted to calculate my self-fed of the program. So what, according to the whatever the sizes and the density we are giving, program automatically calculate the self-fed of the member. So here I have to just say Z minus 1 add. My self-fed is calculated. If you say close, so in the tree menu you can see static load cases self-fed SZ equal to minus 1. So in which case it is coming, that you have to check if particular things are not coming into the tree menu, means that particular thing it is not applied into the UR model. So that is the some identification. Now I come to the next is load to masses. Load to masses means it's a called as the mass source in the ETAM. So here we have to define how much the participation you want to consider for the seismic weight calculation. So I will just say self-fed I want 100%, SIDL I want 100%, and the live load I can give 0.25%. So it's depending upon the design engineer, they can calculate. Now you can see here my load to masses things are coming here. Okay, now next, for the next is about the beam loading. I just select this particular beam loading from 4 5 6 levels, 4 5 6 from the tree menu. I just right click and say select, and my all the beams are selected, and I will just say activate. Okay, now in this lay I just of this particular the terrace view, means overhead tank beams. Okay, I just select this particular beams, and now everywhere I'm applying, for the simplicity I'm applying the same load, that is the something 10 kilonewton per meter for on the beam as a UDL. So I just select the beam, come to the beam load, and I just say element. In the element you can say load case name SIDL. I just say replace, and here if you want to consider the uniform, you can consider uniform. If you say concentrated force, it is considered the point load, movement, trapezoidal loading. So various options are available. I will just say minus 10. So you have to check the unit, that is my unit, it's in kilometer meter. I will just say here 10. I will say apply. My load is apply. So refresh it. Now particularly I select the terrace floor, this particular one floor, say activate, and here what I did, I just select the periphery of the beams. I just select the periphery of the beams. Now you can see this periphery, and I will give the load, that is the -5, that is for the only the partition wall it is coming. Apply. Now my this way I can apply the load on the areas. Now here you can see entire thing it is generated. Say save. Okay. Now next is about the assigning the loading to the particular plate elements or for the retaining wall, you can say. First we are applying the load to the retaining wall. So if I select the plate element and the first plate element, I just select the plate element, I just say active. Now here you can see this is my plate element. I will just select this particular first three walls and come to the load, static load, and I will say pressure load in the hydrostatic pressure. In the hydrostatic pressure, it's asking the case name. I just say SIDL. I just say replace linear load on the plate as a plate element. And here I have to give the reference level. I will just say this one. This is my reference level, and my gradient I can just say -10. So into the height it is automatically calculate. So for the study purpose I am just taking this value. Once you apply this value, you can see it is taking the trapezoidal, the triangular loading as a pressure load. So same thing you can apply. Now I come to the second property. Can you hear my sound? Okay. Yeah. So I will just again select this particular plate element, this one area. Just a click here, and then I will say again same values. Just select this one and I just say apply. Now you can see here also from the outer side I can apply the my soil pressure values. Here you can see in this way. So all the level in this level we generate our this thing. So in this way you have to check the values. So how we can define the values. So most important is at the time of the defining we are giving the wrong input, that is the unit is in kilonewton meter. So always you have to check the unit first and then apply the values. So again I just apply the value. I just select this view. Just change the first unit. SIDL replace height is my this one and intensity is my -10. Apply. Same thing I selected the rest of the part. Height is again the same 0. Value is -10. Apply. So I just say active all. Now my entire thing it is generated here. Now you can see entire thing. Next is about the loading of the floor slab, or else you can say one-way, two-way loading. So here for the staircase only we are doing the two-way loading because it's not a normal staircase. It's not the two-legged staircase. So in that particular area we can consider as a two-way loading, and the rest of the all the places we are considering the one-way loading, because if you see the plan, so I will just open the one level. I just say XY plane, I just select and I just say active. Now in this area you can see everywhere it's a span is very short, so we can consider here as a one-way loading. So in this particular center portion we can consider as a two-way loading. So first is we have to define the cases, means we have to generate the group first, and according to the grouping we have to define the our values. I just say assign, come to the loads, static loads, and here assign floor loads. You have to consider a defined floor load type. So in the defined floor load type, I just say come here, name, say typical, change the unit first, define, first is typical, my sulfate is minus 2.5, my SIDL is minus 2, and my live load is minus 2. Say add. So this is my typical floor load. For the roof, my sulfate is same, but my SIDL is different. So I will just come to the my PPT. Okay, so my dead load, this one is okay. For the roof is my 2.5 and the SIDL is 3.25. Say 3.25, and I will just say add. And for staircase, my sulfate is 4.375. If you do not model the slab, you have to consider the kilonewton per meter square value of the particular slab thickness in the dead load. SIDL is 2 and the live load is 3. Only we are defining the load. So if in case something the load and this thing is changing, so you can directly come and you can change this load also. So it is wherever you are applying this load, it is automatically modified. So this is only the template, or we can say it's only the grouping we are defining. So now we are come to the modeling part, means again loading, assigning up the loading. I just click on the assign floor loads. Once I click on the assign floor load, it is asking the load type. I can say typical. Distribution, I will say one way. And if I say it's a global Z, okay. Now copy floor load. I just say copy floor load. I can copy from the above two levels also. I can say Z, and here I can say 2 at the rate 5 means what? 2 times 5 meter. If you see our PPT, in the PPT, my 2 level, we are at the this level. So my second is 5 meter and the 5 meter. So all the my geometry is almost similar. Only the thing is in this particular portion, it is not there. So we are not assigned the load at particular this level first. One way, I just select here, first point, second, third, fourth, and this one. Now if you see the 3D view, now you can see everywhere it is considered the one-way loading. At the time of the one-way loading, it is asking the angle also. You can define the angle also. Now again I click here, first node, second, third, fourth, and this one. Similarly, this much area, this area, and for this area you can say 90°, this area, and for this we can say two-way, and my load type is staircase, and I can just select here first, second, third, fourth, and the fifth. So you can see here it automatically transfer the two-way loading according to the shorter span as a triangular and the longer span as a trapezoidal. So it is automatically calculated. So everywhere the loading are coming, only this area is remaining. So I can just again say here one-way loading. It's a typical. Now I just remove my copy floor load. I just click here, second node, third, fourth, and the fifth. So it is generated. So sorry, it's a 0°. First node, second, third, fourth, and the fifth. So now it is generated here. I will just say see control all. In the control all you can see Again I select this area, say activate. Now in this area again I just come to the one-way loading. Again I select this particular area. Now if I close it, now in the tree menu also you can see all these loads are coming. If I right click here and I just say display, now you can see all the my values. Okay, if I change the unit, then also you can see the values. Okay, so in this way you can directly get the value per meter. Now next is again I applying the other floors. I just select this particular one level, this level. I just unlock this and display these values. Now I just click here. My one level is generated. This is my one level. Now in this level, again I will just say assign floor loads, a typical one way. Now at the time of the copy floor load, I will do these things also. My 5 times 3.8 meter, because already we are in this level. So 1, 2, 3, 4, 5, 5 times 3.8 meter height, then 4.2 meter height. So what we can do is we can directly assign this type of the loading, copy floor load 5 times 3.8 meter, then 4.2 meter. So after the 5.38 meter, 5 times of 3.8 meter, again it's go for the 4.8 meter. I will just click here first. Everywhere right now we are considering the same value. If the something is happened wrong, so it is not take the value, means certain whatever the value we are inputting in the distance form, if it is wrong, so it's not take the values. And if I say two-way staircase, and I will just select here. Okay. You can see entire thing it is generated. Now next is I just select the my roof level. Now in the roof level I will apply the my loading. So at the time of the applying the loading in the roof level, say roof, say one way. Now I just off this my loading. I will just click the these nodes. I will just select these nodes. And here it's staircase. It's two-way. In this way. So for the top portion, means for the this one portion, if you want you can generate the next new property also, or else you can give your the same values also. Right now I'm giving the same value as of the typical floors, and I consider here two-way loading. So in this way I just apply the my loading. So for the hidden view you can click on this option hidden, so you can see this area. So okay, so you were asking about the one more option is what is the 0 and the 90 degree. 90 degree and 0 means if you want the direction, the one way direction is the horizontal, so you have to say angle is 0. If you say vertically, if you want to distribute the my one way loading, so you have to say 90 degree. So that is the option we have. So once you click here, now you can see two-way, there is a no option because it's automatically take care. But if you say one way, so you have to click whether it is the which direction, in the X direction or it is in the Y direction. Even it is mentioned here also, angle A1 or A2, whatever the, so it is mentioned here, A1 the angle you have to mention here. Okay, now next is first we define the seismic loading and then we define the wind loading. So at the time of the seismic loading, I will just click on the first seismic load and then I will just say add. So one more option is whenever you generate the structure and this story, okay, this particular story, now with this option it is there, the floor diaphragm it is considered. So automatically take care of the diaphragm. So if I wanted to see the diaphragm, so I was just open the one floor. Yeah, this is the one floor. Now I will just go to the my display view, and in the display view I will go to the boundary, and in the last option story diaphragm. If I say apply, now you can see diaphragms are there. So according to the rigid diaphragm, it is considered the your lateral loadings. If you want to consider the flexible diaphragm, so you have to say do not consider in the story box. Means I will just come to the control data story, and here you have to say do not consider, means it is the semi-rigid diaphragm. Okay, now I come to the next option about the, yeah, load, seismic load. I just say add EQX. My seismic load is, case is load code is UBC 1997. Soil profile type is SC. Seismic zone factor 2B, and my importance factor is 1. Period calculation, again click on the period calculator and you have to select the formula according to the which formula you wanted to calculate. So it is depending upon the design engineer or the structure also, means which formula they wanted to calculate. If they do not want to calculate, they can directly manually type the values here. Then ductility coefficient, that is the R value, I can say 4 meter, sorry 4.5 and the 4.5. Seismic zone I want in the scale in the only in the one direction. For the Y I will say 0, and the accidental eccentricity, that is the positive and the negative, earthquake X positive, earthquake Y positive, earthquake X negative, earthquake Y negative, this type of the things you want. So you have to always click on this eccentricity. Right now I am not considering, so I will just off this option. If you want to consider the torsional amplification, so you have to click on these two options. Then you have to come to the seismic load profile. You can see the profile. If you come to the story shear, you can see the story shear, and this is the weight according to the every floor wise. This is the elevation, then seismic force, if any additional load, what is my story force, story shear, and what overturning moment. If I wanted to know about the detailed calculation, just click on the make seismic load calculation sheet. Okay, so in this way you can see the CA and the CV value, it is calculated by the program, and what is my seismic weight and what is my coefficient. So according to the what is my base shear, it is generated here, and in the tabular format you can see all these values. Now the one question is asking, if I select the positive moment amplification, and what is the meaning that, okay, so means if you select the positive and if you do not click on the torsional amplification, so means what happen if the building going the eccentricity, that is the more than the 0 15% of 5% of the plant dimension, so it's not generate the torsional moment. It's only consider the this accidental eccentricities only. So if you wanted to consider the torsional effect also, so you have to click on these options. I will just say apply. Now next is again earthquake Y, UBC, SC, same thing, only the X is 0, Y is 1, and I will just say seismic load profile. Now you can click here, you can see the profile, I will just say okay, my X and the Y it is generated. So torsion amplification, it is the two options we have. Okay, so there are the two methods. First is accidental eccentricity. If you click on the accidental eccentricity, so it is only consider about the 5% of the plant dimension. According to that, it is calculate the positive and the negative these things. But if you wanted to consider the some torsional, the whatever the torsion moment beyond the accidental eccentricity, so you have to click on the accidental eccentricity. And inherent eccentricity means what happened. So because if it is the within the limit and then some torsion it is coming, so it is calculated. So for the more detail you can see the analysis, our analysis manual also. In that it's mentioned about the more detail how it is calculated according to the which formula, means how much it is calculated. If you not consider, then how it is going to be work. So you have to come to the help. In the help menu content you can get the our help menu, that is the online help menu. In the our online help menu also you can see the all the functions are available. If I just go to the loads, static, lateral, seismic. Yeah, so here torsional accidental eccentricity, check whether it is or not to apply amplification to a torsion due to the accidental eccentricity, and check whether or not apply amplification to a torsion due to the eccentricity between the center of mass and the center of stiffness of the building. So depending upon this you have to consider whether you wanted to consider or not. And once you say okay, then if you come to the loading in the tree menu, now you can see earthquake X, right click, say display, you can see the value in the X direction. And the similarly for the earthquake Y, I just say display, I can see the value in the Y direction. So both the options are available. I just right click and say on display, all these things are gone. Now I come to the wind loads, add, I will just say WX1, ASC 710, my basic wind speed is 100. Exposure C, mean roof height, it is calculated by the program. If you say the gust factor value also you can give, or else if you click here and just say calculate, then also the program it is calculated. So these both the options are available. Then wind eccentricity, according to the ASC 710 we have the formula. So the 12 load cases we have. First is, if you click on the flexible structure and if you click here, so according to that it's asking the natural frequency, y natural frequency and the damping ratio. So according to this value you have to input it, and then according to that it is calculated. So it's depending upon the natural frequency. So it is program, it is not calculated, you have to manually input the data and then it is going for the calculation. So one I just say wind load profile, you can see the profile. Story shear also you can see the floor wise, what is my pressure, loaded height, breadth, wind force, story force, entire thing it is mentioned here. If you click on the wind load profile, so according to the which formula it is calculated, it is mentioned here. So what is my F, what is my P, so everything is here. If you come down, each and every floor wise, what is my story, loaded height, breadth, wind force, entire thing it is mentioned here. So each and every case you can draw, you can plot this graph also, and even you can see the values. I just say apply. For wind Y, my X is 0 and Y is 1. Apply. Third case, it is 0.75 in the both direction. None, none, apply. Fourth case, it is minus 0.75. Fifth case, X direction 75% positive, apply. Six is negative, apply. Seventh is, so it's depending upon the your uh, ASC 710. So you have to just go through the code base. So according to that you can get the values, coefficients. Now I consider the Windex 9, that is 0.563, and this is 0.563, and that is the positive, both direction positive, apply. My X is negative, Y is positive, apply. 11th is my X is positive, Y is negative, apply. And the lastly is 12 load cases, both are negative, okay. So according to that, my all the load cases are generated here. So in this way you can generate your load combination, load cases of the lateral load cases. Now next stage is define the response spectrum analysis. So you have to come to the dynamic analysis and just say RS function. Just click on the RS function and just say add. Once you say add, here is asking design spectrum. Just click on the design spectrum. Just say UBC, SC, 2B. Just say OK. And here it you have to say acceleration and just say OK. So my acceleration, this is the thing is generated, and then I just come to the RX load case. My load case name is RX, direction is XY, angle is 0 means in the X direction. Scale factor initially I consider here 1. Generally in ATAB you are considering G by R value, but here no need to generate the G by R value, it is automatically take care. So you have to directly consider only the scale factor as a 1, and then UBC value, and then accidental eccentricity if you wanted to consider, and then you have to say add. This is for the RY, RX. Similarly for RY, the angle is 90 degree. Rest of the things are same. Say add and just say close. So if I come to the tree menu, now you can see my spectrum analysis is also defined, but still I have not defined about the dynamic analysis. So come to the analysis and you have to say eigenvalue. In the eigenvalue, you have to give the reached vector or the Lancaster's method, that is the eigenvector. So if you say Lancaster's method, just say 10 number of mode shape, that is the number of frequency means it's number of mode shape. I just click OK. Now you can see here in the tree menu, this eigenvalue analysis it is coming. What are the things you are doing? Entire thing it is coming in the tree menu. Now I will just run my model. So within few seconds my entire model analysis is run. Yeah. Now next is about the result. Before checking the result, no, here no need to mesh the wall, because in the wall it is automatically take care, the rotational stiffness matrix is take care by the program, and the middle one portion it is considered as the rigid zone, and the top portion also it is considered as the rigid zone. So the formation of the wall is different as of in the what you have in the ETAP. So that's why in the ETAP you required to mesh the wall, but in the MIDAS no need to mesh the wall. If you want you can mesh it also, it's up to you, but if you meshed it, so according to the plate element you have to design, means according to the FEM analysis you have to design your wall. Now next is come to the results. Yeah, plate means shell here. No, no, it is a plate means here shell element. So it's take the in plane and out of the plane both the movement, because at the time of the defining the thickness, it is asking here in plane and out of the plane. If you do not want to consider it, then you have to say in plane. So you can give the in plane value. Don't give the value in out of the plane, or otherwise don't give the value in plane. Give the value in the out of the plane. So in this option also you can use. Now come to the results. Say reaction. I just say reaction, force and movement. I can select the any load case and I will just say FZ value and apply. Now you can see here the bottom whatever the values are there. If you want, you can just click the this one also, bottom nodes, and just say activate, and you can see the value. It is a red, it is coming means the maximum value at this particular point. Okay, now I wanted into the tabular format. So you can just click on the next to the reaction force and moment, this dot dot option. Just click here. Now here I am just selecting my for the exported means you can export it to the safe also. It is depending upon you, but only the thing is through the Excel sheet you can export to the safe, not by a direct option. Okay, so means whatever the load cases. Now you can see here. I will just select whatever the value I am getting. If I say none, okay. Now you can see this is the value I am getting. Just file. I just say export to the Excel, and from the Excel you can import it into the save file. Okay, so each and every node and these things you have to match it. Once the entire thing it is matched, then you can apply the loading. Now again I come to the active record. I just open my values Rx and Ry and earthquake X and earthquake Y. I will just say okay. Now you can see here 482 and my value is Rx is 1342 and 482 and 1267. So almost 3 point something value it is coming. Okay. And similarly for the other direction also the my something 3 point something or else 4 something value it is coming. So I will just close this value, and then we have the one option that is come first is come to the load, dynamic load and the Rx load case. You can directly give the scale factor here, but when you give the scale factor here you have to unlock the model. If you do not wanted to unlock the model, you can directly consider in the load combination. So just come to the results, load combination, go to the concrete design, say auto generation, and in the auto generation you have to select which code. I will say ACI 31811, RX is whatever something 3.3 it is coming, 3.5 I will say, add, and for Y my value it is coming something 4.1 or else 4 I can say, add. So this is my scale factor, means which wherever I am using the Rx load case as a combination, it is automatically multiplied with these 3.5 values and 4 values. If I say okay, my all combinations are generated. If you see into the any these things also, here also you can see 1.2 into 1 into 3.5 Rx plus Rx in the other direction, means here you can see it's 3.5, it is automatically considered. If you want, you just click here and you can change the factor here. So program automatically generate the combination, and if you want you can modify it also. If you want to add it, then also at the go to the bottom and you can add the new combination also. If you want to generate the envelope combination, program automatically generate the envelope combination, as well as the program generate the serviceability combination also. So here you can see this is the serviceability combinations are available, and if you go down up, here it is the strength combinations are available, that is for the designing. If I come to the general and if I say auto generation, in the auto generation we have this option add envelope. So program automatically generate the envelope for the strength as well as the serviceability also. Now I want to see the some results. Deformation, deform shape, something any earthquake X direction, animation, apply. If I say record, this animation is going on. And this animation you can save into the AVI format. Similarly, come to the forces, sorry, forces, say beam diagram, plate diagram, wall diagram, everything you can see here. I will just show you first the beam diagram. I just click on the beam diagram. I can select the combination MY total 4 point values and in the all direction say OK. I will just zoom at one level. So here you can see it is calculated in this way. Dx means only it is in the x direction. Dx, y, z means translation in the x, y and the z in the three direction. So it's depending upon the user how we can check. Right now, if you say earthquake x, so it is purely in the x direction. You can check only in the dx also. If you take the some combination, then you can check the dx, y, z. So in the which direction building is moving. So for that reason, we have the option that is the dx, y, z. Yeah, you can make the torsion also. So it's depending upon the user. Right now for the showing purpose, I am only taking the DX. So if you want, you can select the DXYZ also. It's up to the design engineer. And same way for the beam combination, if you want to see the results, you can just click on the quick view. I just click here, and from the quick view, I can select the combination. I can select the component, and if I select this beam, I can see the values. Okay, now these values are, if you click anywhere, so if you type the value also, if I say 2 meter, enter, so at the 2 meter enter, what is the values are there? You can enter the value, the length, and you can see the value, or else you can click anywhere, then also you can see the value. No need to, here no need to click the right click. You have to always click on the quick view and then select the member. Then one window is there. In the same window, you can change the combination, you can change the component, and you can click anywhere and see the values. These options are available. And if you want to see in the detail format, so just come to click here, beam detail, say beam detail analysis. If I click on this point, in this window, you can see what is my displacement, what is my shear force, and what is my bending moment diagram. Red value means you can click here, it is the dimension, you can click here and you can input the values also. At the 3 meter, what is my value? So it is calculated according to that. So in this way, you can see the values. MIDAS civil file you cannot open directly in the MIDAS gen, but through the MGT command you can open. But some of the file you cannot see the some of the commands it's not working in the MIDAS gen as per the MIDAS civil, and some of the MIDAS gen functions are not working as per the MIDAS civil. So according to the some table or according to the some this MGT file you can import the functions. So whenever you just come here file and you have to say export, and we have some option MIDAGen MGT file, MXT file, AutoCAD file, MIDAS drawing file, frame section for solid. So these options are available, and if it is the same options are available, and just come to the import and check which are the import options are available. So these are the some option, it is taken care by the file. Now next is about the mode shape. Mode shape, just sorry, for the wall, forces come to the wall diagram. So before going to the wall diagram, I just open my only the walls. So I just select the combination MYMZ value in the all, apply. Now here you can see each and every wall, my movement diagram, these things. At the time of the modeling, we already defined the pier. So if you wanted to see here, just click. So just come to the display and you have to come to the element and you have to say wall ID. Okay, so you can see here for the both the walls, I'm giving the numbering as a 1. That's why it is coming here. If you want, you can change it also. For one wall, you can give the different wall ID, and for other wall, you can give the different wall ID. Wall ID means it's a peer label. If you meshed also, then also if you give the one numbering, so it's take the one numbering. You have to come to the nodes and element and you have to say change parameter. In the change parameter, we have this option wall ID. In the wall ID, here you can give the property name, means wall ID or peer label, and you can select which wall you wanted to give the numbering and you have to say apply. So according to that, it's take the wall ID. So these options are available in the nodes and element, change parameter, wall ID. You can give your own wall ID. No, for the core you cannot design by using the MIDAS software. You have to use the design plus. Here it is only the rectangular wall you can design. So for the rectangular wall, you can give the one label. If you wanted to give the one core as a one label, so it's give the one stresses. So according to the one stresses, you can take the forces and you can design manually. And if you want to be a program to be designed, so each and every wall you have to give the different wall ID. Otherwise you can use the design plus for the fastest working, means in that you can design the E shape or C shape or any odd shape of the shear wall also you can design, and it is linked with the MIDAS gen. So that particular wall you have to select it here, so it is automatically linked in the MIDAS gen, MIDAS design plus. Now I come to the result. Yes, irregular shape also you can design by using the MIDAS design plus. Yes, design plus. Design plus irregular core, any type of the core also you can design by using the design plus. And it is considered as a one unit, means as a one core. If you wanted to consider as a different wall ID, then you can use it in the MIDAS, means here you can design only the rectangular shear walls. Okay. Now the next is come to the result. I will just come to the mode shape. I will say vibration mode shape. Here, if I click on this dot option next to the vibration mode shape, you can see the results. So what is my second period? And for the model participating mass ratio, here you can see if I'm giving the number of mode shape is 10. So 10 for the X it is 89 and for Y also it is 89. So I have to increase my number of mode shape. So for increasing the number of mode shape, you have to unlock the model, come to the analysis, eigenvalue, and here you have to give the number of frequency. You have to increase the number of frequency. Mr. Ruby Sunil, if you wanted to open the MIDAS civil file in a MIDAS shell through the MGT command shell, you can do it, but it's not the entire model or whatever the some of the command or some of the features. It is not imported into the MIDAS gen because MIDAS civil is basically for the bridge sector, and the MIDAS gen it is for the industrial and the building sector. So some of the commands are not working in the MIDAS gen, or some of the command are not working in the MIDAS civil also. So both of the things are different. So at the time of the import, some of the command or some of the geometry is gone. So you can use the MGT shell, means text editor file, or else you can use the Excel sheet also. From the Excel sheet or from the table also, you can import the data. If I wanted to see the mode shape, I just click on the multiple mode, and in the multiple mode I just select the 5, 6, 7, 8, 9 or 10. Yeah, 5 to 10 mode shape. I just click here. So in one window you can see the various mode shape of the structures. Yeah, see this is the mode 5, 6, 7, 8, 9, 10. So in this way you can see the mode shape of the building. I just closed it. Yeah. Now next is it's about the result part. If I come to the result, and in the result table, if you want to animate, I will just come to the vibration mode shape, select any mode shape and just say animation, apply, and just say record. Now you can see the animation. If you want to do it for all, so you have to select the all mode shape. So you have to select all the, you have to click on this option. So you have to click on this option, the next option, that is the this one. It is going beyond the limit. So according to that you can see the various these things. For that reason we require the full these things. So I just close the some windows. Now record means if you click means record means the repeatedly it shows the animation. If you do not click on the record, you cannot see the animation. See here, all 1, 2, 3. See all these three windows, you can see the animation. If you say record means it's continuously play the animation, otherwise you cannot see the animation. Now next is about come to the results. If you want some results, come to the result table, and in the story you can see the story drift, story displacement, story mode shape, entire thing it is in the one tabular format. Okay, whatever you click on the years, the same thing you can see from the year. If I say story drift, I can select earthquake X case. Similarly, I can select the wind case also, and the spectrum cases also. Right now I am selecting only for the X direction. Okay, deflection amplification factor CD value according to ASC 710. In that some one graph is there. According to the that you can apply this value for the combination. Then you have to importance factor. You have to select the importance factor. What are the importance factor? And then second is scale factor, whichever the scale factor for the response spectrum you are considering. So you can use there allowable ratio here, and for the combination here you can select SW how much percentage you want, and the SIDL how much percentage, and the LIO how much percent you want. So with the gravity loading you can combine you can check the story drift also. So here you have to give the manually. No, for the existing combo you cannot check. You have to select the combination here. Generally we are checking only for the purely cases. So you have to check by here itself. I just say okay. Now here it is showing that whether it is pass or not according to the allowable ratio. If my allowable ratio is 0.015, my value it is coming is 0.0052. So it is okay. Similarly, this is for the center of mass. So for a center of mass, and this is for the vertical element. So it is checking for both the things and give the result. Similarly, various options are available in the result table story, the weight irregularity check parameter, and various options are available. According to that, you can check. I just open these things. I just open any one value. Yeah. Here it is means node, story drift, modified drift, and story drift ratio. And this is the remark whether it is passing or not. This is for the vertical element. This is for the center of mass, or we can say according to the CG wise. So whatever the values are coming. Okay. It is the vertical load combination. Which type of the generally we are checking for the center of mass, so you have to check only the drift at the center of mass. If you wanted to check for the element wise, so you have to click on the this first option, that is the drift at the vertical elements. So it's depending upon you on the which point you wanted to check. Generally we are checking only for the center of mass. Okay. Now similarly, now the next thing is I have to come to the design. Now in the designing we have the one option, that is the first is general design parameter, just say definition of frame. In the definition of the frame, auto calculate the effective length factor, so that program is automatically calculate the effective length factor. I just say okay. Now for the general design parameter, second option is available, member assignment. Member assignment means what happen, if I say automatic, say all. So if the member is divided into the number of parts, means I just select here activate. Now you can see this particular beam. This particular beam from the column to column, it is break into the two parts. But if I don't wanted to design into the two part, I wanted to consider as a 1 point and the 2 point. So you have to click on the from 1 point to second point, means as a total length. So you have to use the member assignment, so that program does not consider the break element length. It is considered the total length. And if you consider the automatic and all, so first program calculate the column to column as a first length or total length, and then it is go for the secondary element. Then come to the general design parameter. If you want to give your own effective length factor, just come to the effective length factor. We have this option K1, KY, and this one. Yes, for the column also you can do. Means I just open the member assignment. I just see somewhere it is there or not. Just say manual by selection. I will select these two columns, these two break column, and I will say apply. Now in the last option you can see I just double click here. If I double click here, then also you can easily identify. See this 245. If I double click here, you can see this is the single member considered by the program. No, for the column it is not considered, it is for the beam. So for the beam, it is automatically considered. For the column, you have to say you wanted to consider or not. Or else at the time of the modeling also do not break the member. You can consider as a single element from year to year. That also you can do it. Next is come to the RC design, say design code. I will select the code is ACI 31811. If you wanted to consider the ductile detailing, you can click on the special provision of seismic for a seismic design. According to that, you have to select whether it is special movement, whether it is intermediate, whether it is ordinary movement. And again, you can click on the special RC structure for a wall, structure wall. You can select for the shear wall also. Similarly, if you do not wanted to consider the secondary beam or cantilever beam in the ductile detailing, this option is already available. Or if you do not wanted to design the torsion beam, so this option is also available, torsion design. I will just check off this option. We are designing only the normal beam. I just click here. Then come to the RC design, concrete, modify concrete material. In the modify concrete material, now here I have to define the which type of the my grade and this thing is available. So it is automatically take care by the program what is the grade we are using, and the rebar selection you have to mention here. For the ASTM, which type of the grade you are using. Modify, same thing, grade 30, M30 grade. What is my rebar selection? ASTM. Here I have to give the my rebar F5 values. The main rebar means for the main reinforcement, and the sub that is for the shear reinforcement. Then RC design, design criteria for rebar. For the beam, I want 16 mm, 20 mm, 25 mm bar, stirrups 10 mm, or it's a 450. That's why I consider the 4 leg. I can give the cover. This is for the common for all. And the later one, if you want, you can do it the single for the each and every member also you can give. So for the column, I will just suggest 25, 32. It's 10 mm, 4 legs I can consider. Cover is 40 mm. Okay, for the rebar set, I will just show you 1 minute. Bracing also we can do it by ear itself. I just select the this type of the bars. Okay, this from 12 to 16, the cover. I will just select the cover and just say OK. Now if you wanted to change the bar, just come to the tools and just say preference. Okay, come to the tools and the preference. In the preference, in the design, you have to say rebar material. Here you have to select the rebar, which type of the material you want. That is the STM, and the grade also you can select. So according to that it is there. Okay. So from the preferences, you can change the all the data. And from the unit system you can change the this unit also, means if you want to consider the which type of the unit, heat in the which direction, temperature we are generally taking into the Celsius, so always take the C value set, means this type of the things are manually, all these things are available here. Now come to the design, RC design criteria for rebar by member, means by each and every member wise for the beam, column, brace, wall, you can define your own rebar, means the how the program calculate the rebars, because here we are using the 450 mm. So if for the 450 mm you can say 4 leg, but for 300 by 600 you cannot say it's a 4 leg stirrups you want. So for the each and every member also you can give the design criteria of rebars. Next is you can define your own rebars also, that is the modification, modify the beam rebar, column rebar, brace rebar, so you can define your own rebar and you can check also. Now I'm just doing for the some 2-3 members, so I just come here, I will just select some beams. Okay, these are the some beams I'm selecting, RC design, concrete design, and just say beam design. Okay, now you can see property. So property wise you can see the value, but I wanted to see by the member wise, means now I'm selecting so many members. So click on the member. So now in the member you can see the values. So in this way you can see this is the my beam size, HB and HC. What is my FY values? I'm considering position, start, mid, end. No, program automatically consider which is the beam. If it is the horizontal, it is considered as a beam. If it is the vertical, it is considered as a column. If it is the inclined, it is considered as a brace. If you wanted to define it, then also you can define. For definition, you have to come to the general design parameter. And here you have to say modify member type. So in this modify member type, you have to say whether you wanted to design as a beam, you wanted to design as a column, or you wanted to design as a brace. So you have to the design engineers, if they wanted to design, otherwise program automatically take care. Yes, it is designed separately, means in the program now I am designing only the beam, so it is only design the beam. So I will just tell you. Yes, it is the you have to design the separately, means now I'm selecting only the beams, so it is only design the beam. If I select the column also, then also it is not going for the design, because I'm giving the command to design the beam only. So whatever the horizontal members are there, it is act as a beam. So it is designed according to that. Now you can see here what is my position, start, mid, end, what is my negative movements, what is my load combination, and what is my AST top. If I change the unit, if I say mm, now you can see my top also. What is my top and these things bottom. Okay, similarly you can see the rebar, you can see positive moments, again load combination, bottom steel, rebar, VU value, load combination, ASV, and the my stirrups. Now if I want to see in the graphical format, I just click here, I just say graphical, I can see my graphically what is my section diagram, what is my moment capacity, what is my shear capacity, entire thing it is mentioned here. If I want in the detail format, I just click here. So in this option you can, in this option you can see, you just click here. So in this option you can see each and every beam, what is my positive bending moment, what is my RC beam design, what is my ASV by FY value. So everywhere it is mentioned the formula. According to that you can do it and you can see. If you wanted to export to the Excel, yes you can do it the Excel also. Here we have one option, copy table. You just copy and paste it to the Excel also. You can directly see into the Excel also. This option is also available. Now one more option is you can see this result for which beam. If you do not, if you wanted to see, I will just show you. Just click on the connect model view and then click here. Now you can see this result for this beam, this result for this beam. So each and every beam you are getting the separate result. It did not give the total value. For each and every beam you can see the different result with within in the detail format or even in the detail the sheet also, graphically also. So it's up to the design engineer how they wanted to see the results. Now next is, if I select the some vertical columns, I just select this particular some columns. Okay, I just selected these four columns. Now I just come to the RC design, concrete code design. I just say column design. Now in the column design, you have to click on the member because we are checking the result by member wise. So this is the member. Now you can see this is my load combination. What is my FIFS value? What is my PU value? What is my moment? AST? What is my vertical rebar? Again load combination, VU value and entire thing. Again you can copy the table. You can export it into the Excel also for your fastest working. Otherwise you click here and just say graphic. You can see the graphically all the values. This is the my column. What is my applied load, MU moment, axial forces and the capacity, PMM interaction diagram, shear force capacity check and the shear force capacity check at the middle. So end and the middle both where it is check. And if you want in the detail, you just click on the detail. It's check for the biaxial and the major axis, minor axis, everywhere it check the results. And it's give the formula also. Here also you can see RCC column design. You can see the major axis, minor axis, the minimum movements. According to that, where it is checking for the eccentricity moment, entire thing it is mentioned with the formula. You can see here column design. This is the RCC column for brace. So all where it is designed by this way. So this all the options are available. You have to just go through the these options. Somewhere it is fail, it is mentioned in this way. See here it is say okay. If it is fail, it is showing in the red color and say not acceptable. So these options are available. And yeah, same for the wall also you can check. RC design, concrete core design, say wall design. Yes, you can see the steel in the geometry also. I will show you. So first I will show you for the wall ID first. I just click here. I can see the my all the vertical rebar, that is the 16 at 400 and the horizontal is 10 at 304. There is a no end bar is required. If you say graphic, you can see the graphically also. And if you say detail, you can see the detail. Now if I come to the particularly this view, see this is the my one top view. If I right click here, design, concrete design result. Here the reinforcement rebar for beam. I want to see the main rebar. Just right click on a screen and say design and just say concrete design result. So you can get this type of the window and then I will say apply. Now here you can see each value, each beam, you can see top and the bottom values. Okay, start, mid, end, same as the ETAB, you are getting the result. Similarly, if you want the result in the area form, just click on the area and now just change the unit to the mm. Now you can see the area of steel. Yeah, you can see this area of steel on the geometry. And the similarly, if you want the shear reinforcement, just click on the shear reinforcement. You can see the area. If you say rebar, you can see the rebar also. 4 turret, 10, 279 center to center. So according to that it is calculated. So this option is also available to check the RCC design and these things. Even the footing design also you can do here itself. Means I just come to the RC design, just say footing design. Now here it's asking the nodal load. I can click on the bottom of the column point. It is 73, it is coming. Here it select the rebar isolated foundation you want or the pile foundation. If you say pile foundation, you have to give the size of the pile diameter of the pile, space, compressive and the tensile values you have to give, and according to that is it's give the pile cap design, not a pile design, pile cap design and number of piles it's give. Now if I say isolated foundation, I will give the allowable SBC. What is my allowable SBC? 300. Yes, design the member for the different combo, because it's for the wash condition it is checked for the different result for the different combinations. So means according to the combination wise it is checked. Whichever the combination we are defining in the concrete designing, according to that combination it is check the design. Now I come to the here, I can see this one. I just say select load combination. Here load combination I am not selecting, just click the load combination, go to the footing design, auto generation. I can generate my load combination for the footing design. Now you can say these are the load combination are here. If you click on this option, so that particular combination it is going for the design. The special load combo for only for the some walls. Yes, you can do it in this way also. I will just show you. First I will show you for the footing design. Just say okay. Reaction force, according to the combination wise you can see axial force, moment, mx and fy. If I go to the option, it is asking the which type of the code you wanted to select. You wanted to design the column for the footing as a axial force and the moment or not. If you want the square footing, so you have to click on the Lx equal to Ly. If you want rectangular, of this option. If you wanted to consider the sulfate or not, just click here, just say okay, say auto design, and just minimize this window. In the back side you can see all this data, 3.3 by 3.4 meter my these things footing size, and my 0.55 means 550 depth is required, ACI 318 code. What is my serviceability factors, what is my PS movement in X and Y direction. For raft you have to model it here, same as in the safe what you are doing, you have to model it here, and then you have to give the subgrade modulus value, and then you can design. No need to go to anywhere, in the MIDAS gen itself you can do. And this is I am showing for the individual column. Now if you come to the RC design, sorry, in the result and the load combination, if I say come to the concrete design, if I say strength means this particular combination it is going for the designing. If you say inactive, so this particular combination is not going for the designing. So you have to click on this option, which type of the combination you wanted to consider for the design. And you are asking about the strip base. No, the further in the MIDAS gen, the rough design is according to the FEM analysis. It is not based on the strip base. Our developer are working on the strip base method, but might after the some time, after the 6 months or after the 1 year, we are launching the strip base method also. Right now we have only the FEM based method. So each and every panel you can get the area of steel as well as the rebar also. So this is about the MIDAS gen, and in the next part we are looking how to use the design plus, means how to take the drawing by using the same model, and similarly how to take the how to generate the drawing by using the D shop, and how to use the design plus by the link with the MIDAS gen. So this is the we are taking the next webinar, that is in the 12th March, sorry, 12th April So we can continue that our session about the drawing generation by using the MIDAS product. So right now, if you have any doubt, you can ask me. Thank you very much. If you have any doubt, you can mail us on the techsupport@midasit.com so that we can give you the reply. And for the same recorded copy, we are record this copy and send you the recorded copy for your reference purpose. So we have your email ID and these things. So whichever the attendees are there, we send you the recorded copies also. Yes, sir. We have your all the data about the you are already registered for this webinar. So we have your email ID also. The whatever that we doing right now today itself. So all these things I send you through the mail. So you just download our video and you can again go through the same video. Thank you, sir. Thank you for patience and if you have any doubts, you can just mail us and we can discuss the further. Thank you. Thank you very much.